Okay, well, good morning, 8th grade. I hope it's going well. Here we are now on 11.6, which is the sum and difference of radicals. Difference of radicals. Okay, so we are going to be adding and subtracting now with our square roots. So if you remember yesterday's lesson, here we had the square root of a times the square root of b equals the square root of ab, right? A times b, we did that yesterday, and that's good. Cha-ching, yay. But today's lesson here, the square root of a plus the square root of b does not equal, does not work. A plus b. Okay, so that is not true. X. So we don't, when we have two things added together in the square root sign, a and b, we do not do this. We don't do a plus b. Okay, if that makes sense. We don't do that at all. So here is what we do instead. So if we have a times to the d power plus b, the square root of d, minus c times the square root of d, guess what we do? We just combine what is out front. We do a plus b minus c, all that times the square root of d. Square root of d is totally unaffected, okay? Whatever's in here doesn't change. You see that? But what's out here that I'm circling in red goes all together and goes in the front. Okay, so let's do an actual problem that's like that. So if you're looking there, near the top, you see example 1. Okay, so example 1. This is what example 1 says. It says 6 times the square root of 7 plus 3 times the square root of 2 minus 2 times the square root of 7. Okay, now what we have to do, it's like terms, it's like a variable. We have to say which ones have matching things in the square root. You see, this guy, I'm underlining in red, he doesn't have any matching, so he's going to stay the same. He's just going to come down here as plus 3 times the square root of 2. Nothing's going to happen. He just goes straight down. He has no partners. But these guys here in green are the same, so I take what's in front, which is a 6 and a minus 2, and I do 6 minus 2, and all of that times the square root. The square root stays the same on the inside, square root of 7. What is 6 minus 2? Well, that's 4. So that's 4 times the square root of 7 plus 3 times the square root of 2. And that right there is all I can do. That's my final answer. I can't get more simplified than that. You may say, that doesn't look very satisfying. And it's not really. But that's as far as we can go. Okay, so let's do a bunch of these here just to get practice. Okay, so what if we have something like this? Example 2. Okay, in example 2, they have 4 times the square root of 2 minus 3 times the square root of 5 plus 2 square root of 7. Now, if I look here, look, 5, 7, 2. You know what? I can't simplify that. None of them are the same. It's like trying to add x, y, and z, right? It doesn't work, so the answer here is no simplification. Okay, that's as simple as it gets. This is the best we can write it. Okay, right here that I'm underlining in green, that's the best we can write. It can't be any more simple. Okay, so let's do some of these on the skill check. So if you're looking down with me on page 475, okay, here's skill check 1. Skill 1. Okay, on skill check 1, look at number 1. 5 to this times the square root of 3 plus the square root of 3. Now this is confusing a little bit because we see this thing that, or there's something that we don't see, and that's a 1, right? There's 1 in front of there. So we can say we have like terms. So the square root of 3 is going to stay, and then we add 5 plus 1, and we get 6 times the square root of 3. Okay, so that's pretty straightforward. If there's nothing in front, remember, there's always a 1. Okay, let's do another one. Still on that skill check. 5 times the square root of 6 plus 2, or sorry, minus 2 times the square root of 6. Okay, what do? We have the like terms, so the square root of 6 stays, and then we say, ooh, look here. We can do, look what we can do here. 5 minus 2. So we have 5 minus 2, which is 3. So our answer is 3 times the square root of 6. Now, sometimes there's only a few that we have in common. So, like if you look at number 4 here, we have 2 times the square root of 2 plus 3 times the square root of 5 minus 5 square root of 2. Okay, which ones have like terms? Well, only the square root of 2 here are in common. So I do 2 minus 5. So 2 minus 5, that's negative 3 times the square root of 2. So I know I'm going to have minus 3 square root of 2, but what do I have here? This guy hasn't changed. 3 times the square root of 5. Doesn't matter that these 3's are the same. Okay, that doesn't mean anything. It's only what is on the square root. So then that's my final answer. 3 times the square root of 5 minus 3 times the square root of 2. Okay, so that's easy. That's straightforward. That takes just, a lot of practice working through it. Now, here's where this lesson gets a little harder, and it's combining what we learned yesterday with today's lesson. So let's say we have something like this. 2 times the square root of 12 plus 8 times the square root of 3. Now you may say, look, these don't have anything in common, and they don't, but look at this. This 12 is not in prime numbers. So what we have to do is we have to do our factor tree for 12, and so that's 2 and 6, which is 3 and 2. Oh, look, we have a matching pair. We have a 2. We have 2 squared, which means we can pull out, right? This is 2 squared, so we can take the square root of that and get 2. So now I have to rewrite this guy, bring him down, and do times, just like we did yesterday's lesson, the 2 that we pulled out, and what's left on the inside here? The 3. Plus, look at this, 8 times the square root of 3. Now, they have matching inside the radical. So what is 2 times 2 here is 4 times the square root of 3 plus 8 times the square root of 3. So what's the overall answer? 12 square root of 3. You see how we did that? We added this 4 and this plus 8, and the insides stayed the same to give us 12 square root of 3. Okay, that's at the bottom of 475. Okay, so if you just want to go over that, see how they did it, that's on the bottom of 475, okay? So let's do example 3, and then maybe we'll get into example 4 as well, and then we'll go for the homework. So example 3, so this one looks like this. We have the square root of 27 plus the square root of 12. Now you say, there's nothing in common, right? But when they're big numbers, what do we always have to do? Factor. So we get 9 and 3, 3 and 3, 4 and 3, 2 and 2. Okay, so I say, what does this guy have in common? Well, he has a 3 and a 3. So that's 3 squared, which when I take the square root is 3. So I know I can pull him out. 3 times the square root of 3, right? The 3 was what was left over, so he comes in there. And then I do this one over here, and I get 2 and 2. So that's 2 squared. I take the square root of that, and that's 2. And what do I have left? The 3. So I'm going to have 2 times the square root of 3, right? This 3 is going to come down there. This 2 is going to go out there. So now when I rewrite this in black, I have 3 times the square root of 3 plus 2 times the square root of 3. Well, now I just do what I learned, right? The 3's make it like terms. So I can just write my answer here. 3 plus 2, which is 5 times the square root of 3. And there is my final answer. Okay, not too bad. Really not too confusing. So that's how you do it. You just do what we did yesterday's lesson, and then you make sure they have like terms, and then you add them together. Okay, so then let's do example 4, which is a little more complicated because, Bob Jones, they love it when it make it harder. If it was easy, they'd be like, not very much fun. So here's example 4. We have, I'm going to write it down here, 3 times the square root of 8 minus 2 times the square root of 18 minus the square root of 12 plus 4 times the square root of 50. Okay, there is a whole lot going on here. A whole lot. Okay, so I just need to do one at a time. See, none of these are in their prime factor. All of them can be factored. So I do 8 is 4 times 2, which is 2 times 2. So I can pull those 2's out. I'm going to have 3, this guy, times the 2's, right? 2 squared, square root equals 2, which that is going to equal 6. And then what's left on the inside here? This little 2. 6 times the square root of 2. Do that in black. 6 times the square root of 2. I did 1. Now I come here, 18 is 2 and 9, which is 3 and 3. So there's my 3's. So now I'm going to pull this 2 comes down times these 3's. And what's left on the inside here is that 2. So square root of 2, which that's 2 times 3 is 6. So I'm going to erase that, and I'm going to have 6 times the square root of 2, Ooh, 6 times the square root of 2. 6 times the square root of 2. Look what happens here. There's a minus sign that's still here. This minus just goes down. So I see that these guys are going to cancel out, right? They're the same thing. Same sign, and 6 minus 6 is 0. So they're gonna cancel out. But we won't do that just yet, because that may be a little confusing. Let's go up here to this 12, and I get 4 and 3, which is, again, 2 and 2. So now I'm going to have minus 2 times the square root of what was left on the inside here was my 3. So there's minus a 2 times the square root of 3. Now I do my 50, and I get 5 and 10, which is 5 and 2. So I get 5 and 5. So I'm going to have plus 5 times the square root of 2, right? How do I get that 2? It's that 2 comes there, and the 5 comes out. Okay, now that I have that, I'm going to erase all of this jibber jabber up in here, and we will see what we have left. Okay, so what's going to happen with these guys right here? 6 minus 6 is 0, so that goes away. That became 0. So now I'm left with negative 2 square root of 3 plus 5 square root of 2. And that is my answer. Okay? So, oh, I'm sorry. I forgot one step. If you go back with me, there was a 4 times the square root of 50. I forgot to multiply. This is not 20. This is not 5. That's not 5 there. That's 4 times 5. So if you're following in the book, 4 times 5, which then becomes 20. So this guy up here is actually not 5. He's 20 times the square root of 2. So let me erase that. Sorry about that. 20 times the square root of 2. So that was the only thing that I messed up on. And so you can see, if you get going too fast, like I was there for a second, you can forget to multiply. When you got down here, I got a 5, and I forgot to multiply it times that 4. So if you do that, you're going to get a slightly wrong answer, obviously. But this is what all that condenses to. Okay, so it's just one step at a time. If you can do that one, if you follow it along, you're going to be in good shape for this lesson, okay? So here we go for the homework. We are on page 477. Hard to believe, huh? 11.6, and the homework for today is 1 through 25 odd, okay? 1 through 25 odd. So only about 13 or 14 problems. Shouldn't take you too long. I hope that makes sense. If you get confused, watch my example and look at the book at the same time, or just look at the book. Think about I went through all those examples, okay? So you guys got it? We're in our last week, people. We're in our last week of school before the summer break is upon us. So, Mr. H, it's over now.